Hey, so I really want to get into our first build video, but we got to get some stuff out of the way first. Once you build something, you're gonna, when you see what it is, it's gonna want to talk to other things that you build. That's one of the main things we're going to be doing on this channel. We'll also be doing some other cool stuff as well. But the basis for the first bunch of videos is we're going to talk about Internet of Things, and we're going to talk about how everything works together and how you can actually make it work in a real way. None of this talking toaster stuff. So in order to do that, we got to talk about how do Internet of Things talk to each other easily in a way that we can all make it work, and how do we have software that's actually going to make it all work together, home automation type stuff. And we'll even talk today about how Arduino works, what the different models of Arduino are, and what we now have that actually kind of replaces Arduino, because Arduino wasn't really ready for the Internet of Things, it was just ready for everything else. So hey, let's give her. Hey, so let's start talking about Arduino. What is Arduino? Is it just some weird word people like to say to be cool? Or nerdy? Nope. That's Arduino. Well, one form of it. This is probably the most popular, widely used Arduino board over the years. It's called the Uno. This one's actually a knockoff of the real thing. This little puppy does a lot of things, but where it originally came from was somebody was teaching university year after year, and their students really needed some sort of a platform to work from. So they designed a board around these cool little Atmel chips. And then over the years, one of their master students actually designed the software for it. And the reason it all worked is the original board design got open sourced, and then the software that they put on it also got open sourced. So this little beauty was released to the world, and people were able to build upon it. Not only could they build upon it by selling these and then building devices. Ever seen a 3D printer? Those really just exist because of this guy. Well, his older brother anyway, or younger brother. But also people could sell them cheaper and cheaper as time goes on. So let's look at a few different models. So this wasn't the first board, but it was the most popular. You can see that it's got power section, analog in. Analog in is really useful because you can basically measure voltages between 0 and 5 volts. A lot of sensors, that's how the sensors talk to them. Then there's some digital sections, so you can keep track of things like the position of a switch on or off, or with the pulse width modulation it's called. We'll talk about that later, but basically it's a way to control things like servos. You can turn lights brighter and dimmer instead of just on and off. And all of this from this little chip in the middle using really simple software language. A simplified version of C, really. So the one limitation of this, you can see that there's really not that many pins, although the number of things you can do with just this board is incredible. One of the things that they added on later on was the beastly Mega. You can see they're similar on one side, and I'll tell you why that's important in a second. But then they've added all of this, which is a huge amount of analog ins and digital in-out. They call it GPIO. GPIO is general purpose in-out. Now, the reason they're similar on the front half is because they always had in the past something called a shield. What a shield was is if you wanted to add certain hardware onto this, you could buy a shield, and each shield would have its own purpose. This one here is to control stepper motors. You can control 4 stepper motors with it. So you can do CNC, that's why it's called a CNC shield. You can see right there. And it just plugs straight on top of the board. Once you straighten out the pins that got bent during shipping. That's nice. So that just plugs straight onto the board, and then you download and install the right drivers for it if that's what the board needs, or you just know which pins to talk to. In the case of the CNC shield, what first happened is somebody designed some software that could run a CNC, and then they built a board that's compatible with it, which is a very cool idea. Another shield we see here, this is a Bluetooth one. You plug it in, download the drivers, you can actually talk to your phone with this. This is a completely general purpose one. It's for prototyping. You can see it basically has a way to plug into the Arduino, and then it has a bunch of empty holes, and you can design your own circuit. A few of them are sort of fairly standard. One of them here is for an LCD. Now, you don't need this board to use this LCD, you just have to hook it up, but it would be also very useful to be able to do it that way. And the last shield I have lying around, this one's a USB one, so if you want to have the Arduino talk to a USB device, this is the shield you'd want. And you can see, not only does it have the pins out where you plug it into the Arduino, but it's got other pins on top. And certain boards, not all are compatible because it depends on which pins they use, can actually be stacked. Now, over the years we've kind of gotten away from shields. People buy individual hardware now. Some of the things you can use with Arduino, this little guy, he measures the moisture content in soil. This is one of the ones we're going to use at some point. This, you probably recognize the front of this. This is a motion detector you might see in security systems. This is an 8x8 LED display. These things are very bright. You can actually put a whole bunch of them beside each other and make a sign if you want. Relay, super important. You can even get multiple relays on one board. These sorts of things can use this low power Arduino 0 to 5 volts and control high powered things like 0 to 120 volts. As long as you're careful and use good practices. Get really crazy, this little guy will tell the Arduino not only the temperature but the humidity. So this is a great thing, we're going to use a lot of these. This is a gas detector. It can detect, smoke. I can't remember which this one does, but I have one that does smoke and one that does gases. And then this little guy controls a stepper motor all by itself. We're going to probably use this one as well. Now there are a lot of other forms of the Arduino here, just have a few here. This is kind of a crazy and fairly rare old version. It was a shrunk down version of the Arduino, but not really shrunk down. Now around the time this exact board came out, this little guy came out. These two have the same base chip in them, so they have the same RAM and the same flash. This guy has a little bit less I/O just because of the number of pins, but not much. Very, very powerful. This guy's called the Nano. I used to use this guy a lot. If you really want to shrink things down, you can use, even this is a little Arduino. You can see it has a lot less pinouts, and the chip itself isn't as powerful, but it plugs straight into a USB. Very cool. Then there is kind of a rare thing, but then they have these cool shields for the Nano. With this you can plug the Nano in, and it's very nice to be able to plug all your sensors in. Because each of these, the black is the sensor wire, or sorry, the blue is the sensor wire, red is your positive, black is your negative. So most sensors will need a positive feed, a negative feed, and then a signal will come back. So this just makes it easy. Kind of seems a little bit weird that you would shrink the thing down and then make it big again, but in this case you actually have a very convenient way to hook a lot of things up. This is great for prototyping. They even got some real weird ones. This is called a lily pad, Arduino compatible. Same chip again as the Uno. This is designed to be sewn into clothing. And there's a whole series of devices that go with it, lights and measurement things. Now the one limiting thing about the original Arduinos is they can't really talk to each other without extra hardware. And originally the extra hardware, the most likely thing you'd use is either Bluetooth, fairly rare, or Ethernet. But to the most part they were on their own. Then a nice company gave us this. You can see how small it is. It's even smaller than the Nano. What this guy is, it's called the ESP8266. What this guy does is it connects to the Arduino board by serial. You can see there's only 8 pins out of it. And it's a Wi-Fi chip. The weird little zigzag pattern on the board is actually the antenna. And with this little guy, the Arduino is able to talk to a network. And that's really, really big because that allows Arduino to be part of the world of Internet of Things. But the story doesn't really stop there. It actually gets way more interesting. One of the things somebody noticed was that the chip on this is actually, in many ways, more powerful than the older Arduino. More RAM, more speed. So what they did is they actually got the Arduino software system. So if you know how to program this, you can use it to program this. And then you can make devices out of this alone. Now the limitation is you only have the 8 pins, but we all know limitations don't stay long. So the next thing that came along was the same device. You can actually see underneath this tin can is basically this whole board, except the board has all the pins on it and they're all accessible. Now there's still a little bit of limitations this as far as input-output goes, because you don't have nearly as many IoT input-outputs and you only have one analog input. But other than that, you take this, you put your Arduino code on it, and it's Wi-Fi capable right away, right out of the box. And these ones come in different sizes. This is this little board just on its own. No reason you can't use that. The main beauty of this board, besides the pins, is you can run it straight off of 5 volt. The main limitation of these guys is everything's 3.3 volts. But we'll talk about how to fix that. And then this big board, somebody actually laid it out a little better here. It seems like it's not as much, but hey, look, everything else is on the back side. So here's a nice small version, although fewer pins. And then I don't really have a version to show you, but there's a new replacement for this guy. One of the limitations is this guy only has one processor in it, and it has to be used either for Wi-Fi or for your code. So when you're running your code, you occasionally have to give it back to the Wi-Fi. But the new one, not only does it have the dual chips, it also has Bluetooth, has way more analog outs. It just has like everything you'd ever want on the board. And as far as costs go, the knockoffs of these, and the knockoffs aren't rip-offs because it's open source. These guys can be had for about $8 Canadian, which is really cheap anywhere else. These guys are only $2 or $3 now. These old guys back here, these are only like $2 and less. And the new ESP32, which is the replacement for this, they're down to about $8 or $9. And you can get some of them that have built-in hardware to handle batteries and charge batteries. So you're going to see on a lot of our stuff, we're going to use this kind of stuff. So now that we know what we're going to be building it with, we need to know how is it all going to talk together. So in our next video, we're going to talk about how do these devices talk to each other, and how do we control all the devices in an intelligent way. I don't want to ruin the surprise, but if you got a Raspberry Pi lying around, it's going to come in handy. Or an old computer, or a chip. We'll get there. For now, thanks for dropping by. Make sure you hit the subscribe. Very important if you want to see all these videos. And thanks for watching.